Well, hey everybody, Mr. Reeves back with you, and today in this video we're going to be talking about graphing linear inequalities or graphing inequalities on the coordinate plane. So these inequalities are going to have two variables, x and y, which means when we graph solutions it will not just be on the number line, it will be on the coordinate plane. But as we often do, before we talk about inequalities, let's talk about an equation. All right, so I'm going to type in an equation here in my handy dandy Desmos calculator. All right, y is equal to 3 times x minus 1. Y is equal to 3 times x minus 1. Remember, every point on that line is a solution to that equation. That equation has a y-intercept of -1 and a slope of 3. I'm going to do this real quick. I'm going to go ahead and put that expression right here. 3 times x1 minus 1, and let's just put in some values. All right, how about if I put in -3, whoops, -3, sorry, that's what I meant. Let's try this again. -3, and then -2, and then -1, and then 0, 1, 2, 3. So nice that it populates it for me. All right, and you can see that every point is on that line, because what's it doing? It's taking those values of x, it's putting them into the expression. It's taking x for the first one, 3 times -3, -9 minus 1 is -10. Up here for 2, 3 times 2 is 6, 6 minus 1 is 5. And you can see that all the points are on the line, right? Makes sense? The line shows all of the solutions to that equation. All right, but what if instead I wanted the values that were less than that? What if I wanted the y values to be less than 3x minus 1? Well, let me do this. Let's make a table. All right, and let's populate it with those same x values. So -3, -2, whoops, -2, -1. Man, I'm having a hard time this morning. Let's try this again. -1, 0, 1, 2, 3. So you notice I have the same x values, all right? But now I want the y values to be less than 3x minus 1. So all I need to do is look at these values that I have here where they're equal and make them smaller. All right, well, what's a value that's smaller than -10? How about -15? What's a value that's smaller than -7? Well, how about -10? I'm just randomly picking values that are smaller than -4. How about -8? Smaller than -1. How about -12? Smaller, see, I'm just looking at these values right here. So 1 was 2, so smaller than 2. How about -5? All right, 2 was 5, smaller than 5. How about 0? And 3 was 8, smaller than 8. How about 4? All right, now take a look at where those values ended up compared to the line. And you will notice, where are they compared to the line? Let me pull up my handy dandy Moby right here. All right, and my original point is on the line, and my new point, let's take a look. So right here, all right, so this value right here is 2. There's the point where it's equal. There's the point where it's less. There's the point where it's equal. There's the point where it's less. All right. So if you go vertically down from the line, all of the less than values are smaller. We can't see the other one, but the other one would come down like this. All right. And this one again would go right there. Okay. So you'll notice, for the equal values, they are on the line. So everywhere on this line, those are the equals, right? And everywhere below it, those are less than values. In fact, now, if I go over here to my inequality that I had, and I change that equals to a less than, you'll notice that it shades the entire area below the line. All right, you'll notice again, all right, everywhere in the shaded area goes down from the line. In fact, I could just do this. I don't even need to limit myself to the values on the table. So from the line, we're going down. These are the less than values. All right, less than the line. And sorry, these should be vertically straight. They're getting crooked, but you get the idea, right? Now you notice, by the way, the line is dashed. And the reason the line is dashed because we just said less than. All right, if we went ahead and changed that to less than or equal to, so let me go down here and pull this up, less than or equal to, now you notice that it is a solid line. So everywhere on the line they are equal to it, and everywhere below the line they are less than it. All right, so let me go back and let me make it equals again. All right, again, now we're back on there. Let me go back up to my table right here. Okay, so again, the values where they were equal is here because you can see 3 times x minus 1. Now I'm going to go back and I'm going to change them so they're greater than 3x minus 1. And I bet you already know what's going to happen. So I need a value greater than negative 10. Well, 0 is greater than negative 10. I need a value greater than negative 7. How about 5? 5 is greater than negative 7. All right, value greater than negative 4 is 0. A value greater than negative 1, again, 0 is equal to negative 1 so value greater than negative 1. How about 5? All right, I need a value for 1 that's greater than 2. How about 10? And for 2, I need a value that's greater than 5. How about 15? Whoops, 15. And for 3, I need a value that's greater than 8. How about 11? Well, now take a look. Let me zoom out so we can see here a little better. Now you see that all of the points are on the other side of the line, right? In fact, if I go back to my handy dandy Moby here and I go to draw arrows, now they're going to go up above it, right? So that one goes up to there, that one goes up to there. So on the line they are equal, but greater than they are above the line. All right. So you can see that. And again, these are not perfectly parallel, but I hope you get the idea and understand that you can go vertical anywhere above the line. Why don't I use the lines on the grid? That'll help me to go straight, right? Okay. All right. Anywhere above that line is going to be greater. Okay. In fact, if we go ahead now and go back here and I change this equals to a greater than symbol. All right, let's do that. Greater than right here. Now you'll see the shading is above the line. Is above the line. And once again, it's dashed because it was greater than, not greater than or equal to. If I want to pull up the greater than or equal to, here we go. And there's our greater than or equal to. Okay, so just a reminder, if we have equals, we get our line, right? If we have less than, we get below the line. Let me go ahead and I'm going to eliminate this extra table right there so we don't have the points, okay? So less than is below the line, but dashed, all right? If we go ahead and go less than or equal to, now it is below the line and solid. If we go greater than, now it's above the line and the line is dashed. And if we go greater than or equal to, now it's above the line and the line is solid. So if you were doing this and you did not have the benefit of Desmos graphing calculator, what would you do? All right, so let me go ahead and take a look here. Darn, I wish this were a graph paper, but we're just going to have to make a sketch then. All right, let me do this and get back here and get that going both ways. All right, so this will have to be a sketch. So there's my coordinate plane. Here is my x-axis. Here is my y-axis. And let's say we have the equation y equals negative 4x plus 2. All right, so if I were asked to graph that, let me go ahead and just mark some little grid lines on here just to give us a little better idea of this sketch. All right, so when I go to graph that equation, remember it's in slope-intercept form. So I'm going to start with the y-intercept, which is 2. All right, and then I'm going to have a slope of negative 4. So I'm going to go down 1, 2, 3, 4, and over 1. And then I'm going to go down 1, 2, 3, 4, and over 1. Or I could go up 1, 2, 3, 4, and to the left 1. Okay, so those would be my points. And if I was graphing the line that was equal, then I would just go ahead and go through all of those points like that, right? But what if instead I said, no, I want this to be y is less than negative 4x plus 2. All right, well, what am I going to do then? Well, then I'm going to make that line a dashed line because it's not equal. And I'm going to find all the values that are less. Now, remember, the less than values go down from the line. The less than values go down from the line. So if I go vertically down from the line, it's going to be down here like this. So what we usually do is then we shade. We go like this. All right, and we say it is this area here below the line. Below the line. Vertically, every solution is below the point on the line, right? And again, if I were to go ahead and make that a less than or equal to, then that line that I had would have to change to a solid line. Okay. In fact, let me do this. Let me change this to blue. All right, so the blue would be y is less than or equal to, what do we have, negative 4x plus 2. All right, and then let me do green. Y is greater than negative 4x plus 2. So if I were to do that, now that line would be dashed. Whoops, it's not dashed, Mr. Reeves. That line would be dashed. So I'm going to put the dashed line on top. And then, of course, the shading is going to go up, right? From there. Instead of going down, we're going to go above the line, right? We're going to go above like that. And so my shading would be up here. And that would be y is greater than negative 4x plus 2. And of course, this one here is y is less than or equal to. All right, so you see how that works? So graph the line. All right, we originally graphed the line y equals negative 4x plus 2 in slope-intercept form. When it's less than, you go down. All right, when it's greater than, you go up. All right, if it's not equal to, it's a dashed line. If it is equal to, it's a solid line. All right, and that is how you graph a linear inequality in slope-intercept form. All right, I think I'm going to end this video here, and I'm going to make a second video where we talk about how to graph a linear equation that is in standard form. All right, until next time, have a great day. Bye.